All right, so this is Math 2350, Chapter 9, Section 1 on Introduction to Limits. So here we'll be looking at functions and graphs, a brief review, limits, a graphical approach, limits, an algebraic approach, and then limits of difference quotients. So basic to the study of calculus is the concept of a limit. So this concept helps us to describe in a precise way the behavior of f of x when x is close but not equal to a particular value c. Now, the graph of the function y equals f of x equals x plus 4 is a graph of the set of all ordered pairs x comma f of x. Now, remember, f of x really is just a y. Well, if we can get it to right, that's just y. But f of x or y depends on how you want to look at it. For example, if x is equal to 2, then f of 2 is equal to 6. So if we plug in 2 here, we get 2 plus 4, which is 6. And so we get 2 comma f of 2 or 2 comma 6. And that's a point on the graph. Now, if a graph, if a given graph, you can read points off the graph directly. So, that's what we're going to do here in this first example. And so we're given these are the values they want us to use, and they want us to find the h of x values. So h of x is basically the y values on that line. So at -2, what we do is we go over 2, and then we're going to go up 1, and that's going to be that point right there. So this is going to be a 1. Now, -1, we go over 1. Now it looks like we go up 1.5. At 0, we go up 2. At 1, we go up 2.5. Now we're at 2, so we go up, and it looks like we're at 3. At 3, it looks like we're at 3.5. And at 4, we're at 4. And so that's what we would do is if we had to read the h of x off of the graph given a certain x. Otherwise, sometimes they give us, like in this case, they'll give us f of x is equal to that. Then they'll say find f of -2. You plug in a -2, and then you find out that would be a 2. Now, that's not the same function as this one is, so it wouldn't give you the same values, but that's kind of how it works. Now, what if we have this one, let f of x equal x plus 1, and we're supposed to discuss the behavior of the values of f of x when x is close to 1. Well, if we say what is f of 1, well, that's going to be a 1 plus 1, so that's going to be 2. So the behavior of f of x when it's close, so we're thinking about what is the limit of f of x as x approaches 1? Well, it's going to be equal to 2 because as we approach it, it's going to be that. And, if we have our line, we have 0, so it's going to look something like that. So when we approach it from 1, it's going to be roughly, here at 2. Okay, so that's how we're going to look at this one, and we're going to get our answer as far as that. So our limit of f of x as x approaches 1. So as x is getting closer to 1, it's getting closer to 2. All right, so this leads us into the definition of a limit. So we write the limit of f of x as x approaches some number, in this case we're calling it a c, is equal to L. Or we can say f of x approaches L as x approaches c. Okay, so if the functional value f of x is close to the single real number L, where whenever x is close but not equal to c, basically on either side of c. So it has to be the same on both sides. So, if we have that line, that's our value of 1. So as we come from this direction, it approaches the 2. And as we came from that direction, it approaches 2. So it has to be equal on both sides. Now note the existence of a limit at c has nothing to do with the value of the function at c. In fact, c may not even be in the domain of f. So it might be outside of the domain, so it doesn't matter. And however, the function must be defined on both sides of c. So it has to be on both sides of c has to be defined. And sometimes what happens is we have an open circle at that value. So it's really not equal to it there. And so, but it's approaching it from the left and the right. And so that's how it works. So in this next example, we're going to see how the values of the function h of x approach two different numbers, and depending on the direction of approach, and it is natural to refer to these values as the limit from the left and the limit from the right. Okay. So what we have is h of x is equal to x minus 2 over the absolute value of x minus 2. And we're looking at as x approaches 2. Now, if we plug in x approaches 2, what do we get? We're going to get 0 over 0. Well, that's undefined, okay? So that means that this limit really does not exist. And so we'll just say D and E. And so what we're supposed to do is graph it. And so let's plug in some X values and some Y values and kind of see what we have. And I don't know where it's going to be. So -2, -1, 0, 1, 2, 3, 4, because we know at 2, it doesn't work. So it has to have some each direction. So maybe let's go 3 each direction. So if we plug in a -2, a -2 is going to be -4, and it's going to be over a 4, so that's going to give us a -1. If we plug in a -1, so -1 -2 is -3 over a +3, so that's a -1. Plug in a 0, it's going to be -2 over 2, so it's going to be a -1. Plug in a 1, it's going to again be a -1. Now 2 we said is nothing because it's undefined because you can't divide by 0 here. And if we plug in 3, 3 minus 2 is 1 over 1, so that's going to be a +1. And if we plug in, that's going to be +1. And if we plug in, that's going to be +1. So the graph then is going to look like the following. So 2 is the point where it doesn't exist. And to the left of it, it's going to be equal to a -1. So basically, at this one, we're going to have open circle, and it's going to go that direction. And here, it's going to be at a +1, and it's going to have an open circle, and it's going to go that direction. So at the 2, it doesn't exist. So this one is 1, this one is -1. Now, we said it doesn't exist because coming in from the right side, the limit would be 1, but coming in from the left side, the limit is equal to a -1. Since those are not equal, then the limit doesn't exist. And so that's kind of a key thing. It doesn't exist because they're not equal coming in from both directions. Now, if we'd had something, if it had been, again, maybe open circle, but it had gone this way and gone this way, coming from the left, it was equal to 1, but coming from the right, it was also 1, and so then we would have a limit. But in this case, we don't have a limit. Okay, so let's stop there and then we'll come back for some more.